Hey folks, this is a short screencast on proving a sequence converges. I'm going to do the example I did in class yesterday. I made a little mistake at the end, and so I want to correct that. So the example was prove that the sequence 3n plus 1 over 7n minus 4 converges to L equals 3/7. In class, I said something I want to expand on a little bit. I said you can look at this and you can see that the limit is 3/7 by using L'Hopital's rule. Well, technically, since n is just a natural number, this isn't a differentiable function or anything. However, you can think of a sequence as a sampling of a function. So if you replace n with an x, then the terms of the sequence are just points on the graph of this nice continuous and differentiable function. So we can apply L'Hopital's rule to this. And L'Hopital's rule says the limit is x goes to infinity of 3x plus 1 over 7x minus 4 is, well, since this goes to infinity as x goes to infinity, and this goes to infinity as x goes to infinity, this limit is an indeterminate form of type infinity over infinity. So we can apply L'Hopital's rule, which says the limit, if it exists, is the same thing as the limit of the derivatives of the numerator and the denominator. So the derivative of the numerator is 3, the derivative of the denominator is 7, so indeed, you see the limit is 3/7. That's from Calc 1. In real analysis, we're going to prove in detail that according to our new definition, right? Our definition is xn converges to L if for every epsilon greater than 0, there is an n that depends upon epsilon that's also greater than 0, such that if n is bigger than capital N, then the distance between the term xn and L is less than epsilon. So we're going to use this definition to prove that the limit of the sequence is indeed 3/7. So let's do a little scratch work. And then the scratch work will inform our proof. So we're going to look at this distance between the nth term and the limit. In our case, that's 3n plus 1 over 7n minus 4 and 3/7. I'm going to write this as a single fraction over this common denominator. I'm going to leave the common denominator that way and just start simplifying. And you'll see in the numerator those 21 n's cancel. And I'm left with 19 over 7n minus 4. So we want this quantity to be less than epsilon. On the left-hand side, you see everything's positive, so I can drop those absolute value signs. I get the same thing. And I really want to solve for n, so I'm going to invert both sides. And inverting in an inequality changes the direction of the inequality. Now let me multiply both sides by 19. I get that. Then divide both sides by 7. I get that. I'm going to add 4 to both sides. I get that. And then I'm going to divide both sides by n. Or sorry, 7, and I get that. So just clean it up a little bit. It's 1/7 of 19 over 7 epsilon plus 4. So my little n is bigger than this, so this number is my candidate for big N. So here's the proof. Let epsilon greater than 0 be given. we must show there is an n greater than 0 with the property that if little n is bigger than capital N, then xn minus L, which in this case is, 3n plus 1 over 7n minus 4 minus 3/7. 3/7 is less than epsilon. So the next step is we're going to choose our n to be this thing we calculated in our scratch work. So I'm just going to recopy this. Choose n to be 1/7 of 19 over 7 epsilon plus 4. And let's let n be bigger than this capital N. For such little n, we see, and so here's where we start recycling our scratch work. We see 3n plus 1 over 7n minus 4 minus 3/7 equals, and really I am just redoing the scratch work that I did previously. I believe this simplifies to 19 over 7 times 7n minus 4. So here's where we're going to start using our facts. So my little n is bigger than capital N. So in this expression, if I replace little n with something smaller, namely big N, it makes my denominator smaller. And if I make my denominator smaller, it makes the whole thing bigger. So I'm going to get something bigger if I replace little n with big N. There's my n. Now I'm subtracting 4 from that. All right, there. I got the parentheses correct. Because this right here is that n, so 7n minus 4. Okay, I'm good. And then we'll, since we have the room, and I think I can finish on this page, we'll move that up there. But let's look down here and see what kind of simplification we get. This 1/7 and that 7th, they cancel. Oops. And now you can see this 4 and that 4, they cancel. And then this 7 and that 7, they cancel. So I'm left with 19 over epsilon. So this is 19 over 19 epsilon, and the 19s clearly cancel, and epsilon is positive, and I end up with epsilon. So I have shown that my expression here, this difference, the distance between the terms of my sequence and the purported limit, is less than epsilon. And so we'll conclude the proof with a statement like, thus, the sequence converges to 3/7. End proof. All right, there you go. Hope this is helpful.